it is not permissible to run 24 volts alternating current, an RG59 coaxial cable in the same polyvinyl chloride or PVC conduit for a security camera installation. The National Electrical Code, or NEC, prohibits running alternating current, power, and low voltage cables like RG59 Coax in the same conduit. This is because alternating current power can induce electrical noise onto the coaxial cable, which can interfere with the camera's signal. This interference can manifest as static, distortion, or a complete loss of signal, rendering the security camera ineffective. The alternating current signal creates an electromagnetic field that can couple with the coaxial cable, introducing unwanted electrical signals. Furthermore, if the alternating current power cable becomes damaged or the conduit becomes flooded, it could create a short circuit and pose a fire or electrocution hazard. The close proximity of the alternating current power cable and the coaxial cable increases the risk of damage to both cables due to friction, heat, or environmental factors. A short circuit in the alternating current power cable could energize the coaxial cable, creating a dangerous situation for anyone who comes into contact with it. Instead of using the same conduit, the recommendation is to run the 24-volt alternating current power and RG59 Coax in separate conduits. This will prevent electrical interference and ensure the safety of the installation. Using separate conduits physically isolates the alternating current power cable from the coaxial cable, preventing electrical noise from interfering with the camera signal. It also reduces the risk of fire or electrocution in the event of a short circuit or other electrical fault. When installing electrical systems, it is crucial to adhere to the National Electrical Code, or NEC, guidelines to ensure safety and prevent potential hazards. The NEC provides detailed requirements for wiring methods, including the separation of power and communication cables. Ignoring these requirements can lead to serious consequences, including electrical shock, fire, and equipment damage. Several factors contribute to the NEC prohibition of running alternating current power and low voltage cables in the same conduit. Firstly, the potential for electromagnetic interference or EMI is significantly increased when these cables are run together. Alternating current power cables generate electromagnetic fields that can induce currents in nearby conductors, including coaxial cables. These induced currents can distort the signal carried by the coaxial cable, resulting in poor video quality or complete signal loss. Secondly, the risk of electrical shock is greater when alternating current power and low voltage cables are in close proximity. If the insulation and alternating current power cable becomes damaged, it can create a path for electrical current to flow to the coaxial cable, potentially energizing it and creating a shock hazard. Thirdly, the potential for fire is increased when alternating current power and low voltage cables are run together. A short circuit in the alternating current power cable can generate a significant amount of heat, which can ignite the insulation on the coaxial cable or other nearby materials. To avoid these risks, it is essential to run alternating current power and low voltage cables in separate conduits or cable trays. This provides physical separation between the cables, reducing the potential for electromagnetic interference, electrical shock, and fire. When selecting conduits for electrical installations, it is important to choose the appropriate type and size for the application. Polyvinyl chloride, or PVC, conduit is a common choice for many electrical installations, but it is not suitable for all applications. For example, polyvinyl chloride, or PVC conduit is not recommended for use in areas where it will be exposed to high temperatures or direct sunlight, as it can become brittle and crack over time. Metallic conduit, such as rigid metal conduit, or RMC, or electrical metallic tubing, or IMT, is a more durable option for these applications. The size of the conduit is also important. The conduit must be large enough to accommodate all of the cables that will be run through it, without overcrowding. Overcrowding can make it difficult to pull the cables through the conduit, and it can also increase the risk of damage to the cables. When installing electrical cables, it is important to follow all applicable codes and regulations. This includes using the correct wiring methods, grounding the electrical system properly, and protecting the cables from physical damage. Failure to follow these guidelines can result in serious consequences, including electrical shock, fire, and equipment damage. In addition to running alternating current power and low voltage cables in separate conduits, there are other steps that can be taken to reduce the potential for electromagnetic interference or EMI. Firstly, shielded coaxial cable can be used. Shielded coaxial cable has a layer of metallic shielding that helps to block electromagnetic interference. Secondly, twisted pair cable can be used for low voltage signals. Twisted pair cable has two conductors that are twisted together, which helps to cancel out electromagnetic interference. Thirdly, filters can be used to remove unwanted noise from the signal. Filters are electronic circuits that are designed to block certain frequencies of signals. Fourthly, grounding the electrical system properly can help to reduce electromagnetic interference, or EMI. Grounding provides a path for electrical current to flow back to the source, which can help to reduce the amount of noise that is present in the system. Maintaining a safe and compliant electrical installation requires careful planning and execution. Here's a breakdown of key considerations. Firstly, conduit selection. Choose the appropriate conduit material and size for the specific application. Consider factors such as environmental conditions, the number of cables to be run, and local electrical codes. Secondly, cable separation. Always run alternating current, or AC, power and low voltage cables in separate conduits to minimize electromagnetic interference, or EMI, and prevent potential hazards. Thirdly, proper grounding. Ensure that the electrical system is properly grounded to provide a safe path for fault currents and minimize the risk of electrical shock. Fourthly, secure connections. Make sure that all electrical connections are tight and secure to prevent loose connections, which can lead to overheating and electrical fires. Fifthly, regular inspections. Conduct regular inspections of the electrical system to identify any potential problems, such as damaged wiring, loose connections, or overloaded circuits. Sixthly, qualified personnel. Always use qualified electricians to perform electrical work to ensure that the installation is safe and compliant with all applicable codes and regulations. Seventhly, overload protection. Install appropriate overload protection devices, such as circuit breakers or fuses, to protect the electrical system from overcurrents. Eighthly, surge protection. Consider installing surge protection devices to protect sensitive electronic equipment from voltage surges. Ninthly, labeling. Label all electrical panels, circuits, and disconnect switches clearly to facilitate troubleshooting and maintenance. Tenthly, documentation. Maintain accurate documentation of the electrical system, including wiring diagrams, panel schedules, and equipment specifications. By following these guidelines, you can help ensure the safety and reliability of the electrical installation and minimize the risk of electrical hazards. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. Additionally, it is important to be aware of the specific electrical codes and regulations that apply to your local area. These codes and regulations may vary depending on the location, so it is essential to check with the local authorities to ensure that the electrical installation complies with all applicable requirements. Some common electrical codes and regulations include the National Electrical Code, or NEC, which is used in the United States, and the Canadian Electrical Code, or SEC, which is used in Canada. These codes provide detailed requirements for electrical installations, covering topics such as wiring methods, grounding, overcurrent protection, and equipment installation. Adhering to these codes is essential for ensuring the safety and reliability of electrical systems. In addition to following electrical codes and regulations, it is also important to use high-quality electrical materials and equipment. Cheap or substandard electrical components can be unreliable and even dangerous. It is always best to invest in quality electrical materials from reputable manufacturers to ensure that the electrical installation is safe and durable. Finally, it is important to remember that electrical work should only be performed by qualified electricians. Electrical work can be dangerous, and it is not something that should be attempted by untrained individuals. Qualified electricians have the knowledge, skills, and experience to perform electrical work safely and correctly. Hiring a qualified electrician is an investment in safety and peace of mind. When working with electrical systems, always remember to prioritize safety. Electrical shock can be fatal, so it is important to take all necessary precautions to protect yourself from electrical hazards. Some basic safety tips include turning off the power before working on any electrical circuits, using insulated tools, and wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves. By following these safety tips, you can minimize the risk of electrical shock and other electrical hazards. Furthermore, always verify that the circuit is energized using a reliable voltage tester before beginning any work. Do not assume that the circuit is off simply because the switch is in the off position. Double check with a voltage tester to ensure that there is no voltage present. If you are unsure about any aspect of electrical safety, consult with a qualified electrician before proceeding. Another important aspect of electrical safety is to be aware of the potential hazards associated with arc flash. Arc flash is a dangerous phenomenon that can occur when there is a short circuit or other electrical fault. Arc flash can generate intense heat and light, and it can cause severe burns, blindness, and even death. To protect yourself from arc flash hazards, it is important to wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields. Arc-rated clothing is designed to protect the wearer from the heat and flames generated by an arc flash. Arc-rated gloves protect the hands from electrical shock and burns. Arc-rated face shields protect the face and eyes from the intense light and heat of an arc flash. It is also important to maintain a safe working distance from energized electrical equipment. The safe working distance is the minimum distance that a person should maintain from energized electrical equipment to avoid the risk of arc flash. The safe working distance varies depending on the voltage of the electrical equipment. In addition to the hazards mentioned above, there are other potential electrical hazards that you should be aware of. These hazards include electrical fires, overloaded circuits, and damaged wiring. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and flammable materials near electrical equipment. Overloaded circuits occur when too much electrical current is flowing through a circuit. This can cause the circuit to overheat and potentially start a fire. Damaged wiring can create a shock hazard and also increase the risk of electrical fires. To prevent electrical fires, it is important to have the electrical system inspected regularly by a qualified electrician. The electrician can identify any potential hazards and make recommendations for repairs or upgrades. It is also important to avoid overloading circuits by plugging too many appliances or devices into a single outlet. Use power strips with built-in circuit breakers to protect against overloads. If you notice any signs of damaged wiring, such as frayed or cracked insulation, have it repaired immediately by a qualified electrician. In conclusion, running alternating current power and low voltage cables in the same conduit is a violation of electrical codes and poses significant safety risks. It is essential to follow the recommendations outlined in this explanation to ensure a safe and compliant electrical installation. Always prioritize safety when working with electrical systems and consult with a qualified electrician if you have any questions or concerns. By taking these precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember, proper planning, execution, and adherence to safety guidelines are crucial for any electrical project.